Hi everyone, my name is Ritika and I'll be guiding you through this lesson, which is all about prime and composite numbers. So here's the objective for this lesson. In this lesson, students will understand the meaning of prime and composite numbers. They will be able to determine if numbers are prime or composite and understand the importance of knowing this concept in math skills. Students will also be capable of completing the necessary process to identify these types of numbers. Some skills that you will have acquired by the end of this lesson include knowing the definitions of prime and composite numbers, using division, and factoring large numbers. The target age group for this lesson is for grades 3 to 5 and is part of the Interns for Good organization. However, before you work through this lesson, make sure you know how to do the following problems. Division, what an even number is, and what an odd number is. So go ahead and work through these problems and take some time on your own. All right, so hopefully you got that 250 divided by 2 was 125. An even number is a number divisible by 2, and some examples are 2, 4, 12, and 262, since all of those numbers can be divided by 2. And an odd number is a number not divisible by 2. So 3, 25, 81, and 107 are numbers that are not divisible by 2, which is why they're odd. So hopefully you were able to correctly divide and know what an even number and odd number was before moving on. All right. Important key terms are prime numbers, composite numbers, and factoring. A prime number is a natural number divisible by only two natural numbers, which are 1 and itself. A composite number is a natural number divisible by numbers other than 1 and itself. And factoring is the method of breaking down a number into smaller numbers. If you forget what these words mean, just come back to this part. Okay, these are the unmathematical definitions that may help you remember these terms. Prime means cannot be broken down any further. Composite means made up of various elements. So how do these definitions relate to the mathematical meanings, and how are they similar? Well, the mathematical definitions are that prime numbers cannot be broken down or factored into smaller numbers, and composite numbers can be factored by various numbers. These definitions include these ones up here. Here are some examples. Let's start with a simple one, the number 2. The number 2 can be divided by 2 and 1. It can be divided or factored by 2 or 1. Since the number 2 is only divisible by 1 in itself, it is a prime number. It cannot be broken down any further. Another example is the number 4. We can divide 4 by 4 and 1, or factor it by 4 and 1, and 2 and 2. So since 4 is divisible by other numbers other than 4 and 1, it is composite. It can be divided by more than 2 sets of factors. The third example is the number 7. 7 can be factored into 7 and 1. And so since 7 is only divisible by 1 in itself, it is prime. It cannot be broken down any further. The final example is the number 9. The number 9 is divisible by 1 and 9 and can be factored into 3 and 3, which means it has numerous factors. So since 9 is divisible by numbers other than 1 and 9, it is a composite number. So now you can do a fun game on your own. If you have a dice at home, roll one die and determine if the number it lands on is prime or composite. But if you do not have die at home, use this die simulator online. So you can roll the dice multiple times if you need lots of practice before we get into tougher problems. For example, if you roll the number 4, you would say that it is a composite number since it can be broken down into 2 and 2 and 1 and 4. So try to get practice on your own for a little bit. Okay, here's a different example. Are there numbers that are neither prime or composite? Well, let's look at the number 1. 1 can only be factored into 1 and 1. So that means the only numbers divisible by 1 is 1 and 1. However, to be prime, a number must be divisible by two different numbers, 1 and the number itself. The number 1 is divisible by 2 of the same numbers, which is why it cannot be prime. So 1 is a number that is neither prime or composite. Can you think of another number that is neither prime or composite? Well, if you said 0, you're right. 0 can be factored into 0 and any number. Prime numbers can only have two factors, which are 1 in itself. But the number 0 has infinite factors. Composite numbers have two different factors, but the only factors 0 has are of itself. So that means 0 is neither prime or composite because it doesn't have multiple factors because 0 has to be a factor. But it can't be prime because it has this number right here can be infinite different things. So you may be confused with the process to know whether a number is prime or composite. Well, a simple way to determine if a number is prime or composite is to list all the factors that it can be divided by. If the number only has two factors, which are 1 in itself, it is prime, but if it has more factors, then it is composite. For example, let's look at the number 17. 17, the factors of 17 are 1 and 17. There aren't any more factors to 17, right? Well, that means 17 is prime then. The second example is the number 25. 25 can be divided by 5 and 5, and it can be divided by 1 and 25. So that means 25 is composite. Listing all the factors is a great way of saying which two numbers multiply up to get this value. However, listing all the factors can be really hard since a number could have so many factors if it's really large. So you may be asking if there's a shortcut. And there is. So the shortcut is that if a number is even, it is always composite except for the number 2. But not all odd numbers are prime. For example, 21 is an odd number but is divisible by 1 and 21 and 7 and 3, and it has multiple factors. But only use this shortcut when you're familiar with this skill, maybe later. So the shortcut is basically that if a number is even, it is composite because all even numbers can be divided by 2. So now we're going to move on and do some harder problems. Are you ready? The following slides will give you more practice with harder problems. Remember that you can always go back and revisit any parts of this lesson if you aren't ready. Okay, let's do it. This is your first problem. The number 81. Is it prime or composite? 81 is composite because it has numerous factors. Look, it can be factored into 1 and 81, 9 and 9, and 3 and 27. Let's go back. So if you don't get the answer right, try to go back, pause the video, and understand the multiple factors that make the number 81 composite. This is your second example. This one is pretty hard, so try your best. Is the number 113 prime or composite? 113 is prime because it only has factors of 1 in 113. You may be thinking that if it's a big number, it would be composite, but it's not because nothing other than 1 in 113 multiply up to get this number. This one is even harder. Is the number 261 prime or composite? 261 is composite because it has numerous factors. It has factors of 1 in 261, 3 and 87, 9 and 29, and that's it. So if you're having trouble thinking of the factors of 261, don't worry, because this was a hard number and you do not need to know all the factors right away. As long as you knew that 261 had factors other than 1 in itself, you would know that it was composite. So basically, if you at least knew one, that it had factors other than 161, you would know that it's composite. So this one required good division skills. And remember that not all odd numbers are prime. This is your last problem. The number 1002. Is it prime or composite? Well, it is composite because it has numerous factors. 1 in 1002, 2 in 501, 3 in 304, and 6 in 107. So now this was a good problem to use a shortcut because you did not need to use this. You do not need to do this much work finding the factors of 1002. Since we know that 1002 was even, we know it could be divided by 2 and some other number. So the 2 was right here. We knew that it could always be divided by 2. Even if we didn't know what this number was, since it was even, it always can be divided by 2. So this is a good problem to use a shortcut because it is even and can be divided by 2. And if you use it, great job. So this is a more practice. Which of these numbers in this sequence is prime? Take a couple minutes and work this out. All right, 8 is not prime because it can be factored by 1, 2, 4, and 8. 14 is not prime either because it can be factored by 1, 2, 7, and 14. 61 is also not prime because it can be factored by 1, 3, 23, and 69. 93 is also not prime because it can be factored by 1, 3, 31, and 93. 151 is prime because it can only be factored by 1 in 151. 681 is not prime because it can be factored by 1, 3, 227, and 681. So in this sequence, the only prime number is 151, and the rest of these numbers are composite. If I went too fast for you, please pause the video and go back and try to work this out on your own. How about this sequence of numbers? Which of these numbers is composite? 1 is neither prime or composite. 29 is not composite because it can only be factored by 29 and 1. 71 is not composite because it can only be factored by 71 and 1. But 108 is factored because it has factors of 1, 2, 3, 4, 6, 9, 12, 18, 27, 36, 54, and 108. It is also an even number, which is how you can tell it is composite too. 137 is not composite because it can only be factored by 1 in itself, and 503 is not composite either because it can only be factored by 1 in itself. So that means the only number that is composite in this sequence is 108, and the rest of these numbers are prime besides 1, because remember, 1 is neither prime or composite. So in this table, some values are highlighted. Are the shaded values in this table prime, composite, or prime and composite? So take a couple minutes, pause the video, and work this out on your own. All right, I'm assuming you've had a go at it. So all these numbers are composite because each number can be divided by more than just 1 in itself. 4 can be divided by 2 and 2. 8 can be factored into 4 and 2. 12 can be factored into 4 and 3 and 6 and 2. 16 can be factored into 2 and 8 and 4 and 4. 15 can be factored into 3 and 5. 6 can be factored into 2 and 3. 10 can be factored into 2 and 5. 14 can be factored into 2 and 7. And 9 can be factored into 3 and 3. So all of these numbers have numerous factors in it, which means they are all composite. How about this table? Are the shaded values in this table prime, composite, or both? All right, the shaded values in this table consist of prime and composite numbers, so both. The numbers 3, 7, and 11 are prime numbers, but remember the number 15 is composite because it has factors of 1 and 15 and 3 and 5. Here are some optional fun assignments. Go outside and make a hopscotch grid with the chalk. Play hopscotch, but determine if the number you land on is prime or composite and list all the factors. You can use the chalk to help you. So basically, once you land on a number, you just determine if a number is prime or composite, and then if it's composite, I would just list all the factors. And this is a fun activity to do when the weather is nice. Otherwise, you can do the second one. Write down the age of everybody in your family and if the numbers are prime, composite, or neither. So if your mom or dad is 45, you would say that if it's prime, composite, and if it's composite, list all the factors because that would help you a lot. So you may be asking why prime and composite numbers are important. So prime numbers are the building block of all numbers, and they will help you solve lots of problems that require factoring and breaking down numbers in high levels of math. Prime and composite numbers are everywhere around you because they make up all the numbers that you see. So they are important because they are the formation and structure of all numbers, and you will see them for the rest of your life. They are also important in computer science. Did you know that computers sometimes use prime numbers in processes called cryptography? Cryptography is when you use coding to establish secure information and techniques in computer science. Coding is kind of like computer language. Large prime numbers are used to secure systems on computers. Isn't that really cool? So if you're interested in computer science, prime and composite numbers are pretty cool to know. So now that we're at the appendix, now that we're at the end of the lesson, we're going to move on to the appendix. So these are some helpful videos, worksheets, and practices. This is a video on factors, multiples, and patterns, and this is another review on prime and composite numbers. This worksheet is just a normal prime and composite worksheet, and this one will make you use the hundreds chart. These are 2 online practices that are really helpful, so I really recommend doing most of these practice assignments. And remember, practice makes perfect, so remember to practice. Okay, so this is a little bit about me. Thank you guys so much for watching. My name is Ritika Pocarel, and I'm 15 years old. I love to run and spend time at the beach. I also enjoy learning and teaching math subjects. All right, guys, bye.